Hello and welcome to our lesson. Today, scholars will determine if a function is linear or nonlinear. Please make sure that you're taking your notes. Okay, so first of all, what does it mean to be linear? So linear means that a function has a constant rate of change. A constant rate of change. The constant rate of change is also called the slope. You guys have found the slopes of linear functions in the past. So now we're going to look to determine if functions are linear or nonlinear. So when we're looking at a graph, it's pretty easy. We're looking for a line. So here I see that I have a line. So this one is linear. This one I'm seeing a curve, so it is not linear. Again, I'm seeing a curve here, so it is not linear. Again, looking at a graph, it's pretty simple. You may see a graph with dots all in a line. That would also be considered linear, as long as they're in a line. Okay, so now, but how do I tell if I'm looking at a table? Again, I'm looking for the constant rate of change. Remember, change is defined as your slope, so that's y2 minus y1 over x2 minus x1. Change in y divided by change in x. So when I'm looking at the table on the left, I see that my y is changing. We're adding 1 each time. My x is changing by increasing by 5 each time. I can see that here. So this one is linear. This next one, again, I'm looking for my change in y. I'm jumping by 3, by 3, by 3, by 3 here. On the x side, I'm increasing by 2, by 2, by 2, by 2. So this one is linear. It's got a slope of 3 over 2. The one over on the left had a slope of 1 over 5. There's change in y over change in x. So when you see them written horizontal like this, make sure that you remember that y still goes on the top. Okay, so I've got another one over here on the far left. My change in my y, I'm increasing by 1. Here I am decreasing by 2. Here I am increasing by 4. Here I'm increasing by 2. But what I'm looking for is the ratio the same. My input here is increasing by 3. Here it's increasing by 3. Here it's increasing by 2. Here it's decreasing by 5. So I'm looking for is 1/3. Ooh, sorry about that. 1/3. Does it equal negative 2 over 3? Does it equal 4 over 2? And does it equal 2 over negative 5? So none of these are equal to each other. So this one is not linear. Remember, I'm looking for equal proportions. Okay. So when I'm looking at an equation, how can I tell if it's linear? So any equation that we can write as y equals mx plus b or ax plus by equals c is linear. So any of them that can be rewritten this way. Here's the big thing to keep in mind. If an equation divides by x, has an exponent on the variable, or has a variable in an exponent, it is not linear. Okay, those are not linear. Okay, if I divide by x, I end up with an asymptote, which is, the graph would look something like this. Ooh, let's try that with a line instead of a highlight. So if it divides by x, my graph would look something like this with a line. If I have an exponent on the variable, anything other than 1, because of course a 1's always there, then I might have a graph that looks like this or like this. If I have a variable in the exponent, I'm going to have a graph that goes up like this or goes down like this. Okay? So just some things to keep in mind for what those graphs might look like. So let's look at each one of these and decide if it's linear. So the first one, y equals 1/2 x minus 5. This is y equals mx plus b. So our m is 1/2, our b is negative 5.8. So this one is linear. Our next one, 5x minus 3y equals 12. Again, that's ax plus by equals c. So this one is linear. This next one, y equals 5 divided by x. We've got an x being divided by. That means that this one is not linear. Because there's a place where when I have a value, whenever we have, where we can't divide by 0. So whenever x is 0, this would not have a value. So in that case, it is not linear. Next one, y equals x squared minus 3x plus 2. This one is not linear. This one is a parabola. This is that one that looks like the U. So this one's not linear. And finally, I've got y equals 3 to the x power. Again, this one is not linear. I have an x, and a variable in my exponent. Okay? So not too bad. Real quick looking at equations to tell if they're linear or nonlinear. Remember that sometimes your linear ones will be written so that you'd have to rewrite them, rearrange them to make them look into the linear forms that we talked about, which is y equals mx plus b or ax plus by equals c. But just think about if you can rewrite them. So finally, why is it linear? So first of all, there are only two answers for this. One, it is linear because it has a constant rate of change. Or two, it is not linear because it does not have a constant rate of change. That's it. That is the only reason things are or are not linear, is they have or do not have a constant rate of change. Okay? So go ahead and do your practice, and I will see you all in class if you have any questions.